With the Summer Olympic Games kicking off in Paris, I thought it would be really interesting to put together my own version of the Olympic Games. And I really wanted to look at how the large language models performed at coding. In today's video, we're going to dive into the thick of the competition and see which model comes out on top. Competing today, we have models from OpenAI, Google, Anthropic, Meta, and DeepSeek. So our Olympic coding event for these LLMs to compete against each other in is going to be the BigCodeBench. It's a practical coding challenge that benchmarks and evaluates the true programming capabilities of these models in a realistic setting. All right, so without further ado, let the games begin. Okay, so popping over to the browser here, I've got my Arc browser and I've got a whole slew of different bookmarks here. The link is in the description below for all of these, so you can peruse and investigate at your own leisure. But I'm gonna go rapid fire here through the intro and get into HumanEval, agents that are really interesting and proposing a whole new paradigm in this whole new coding space. The BigCodeBench exercises, the background behind it, how these models are performing at that particular exercise. I will have these legal protection links here. I'm not going to go through them, but just to let you know, some of these models don't have the same protections as others. So spoiler alert, you need to choose your model appropriately if you're doing things that you care about. And I'll just say that for now. There's examples at the end that I'm going to go through just to show some like real-time output from these models and how they're trying to solve the problems in slightly different ways. So that'll be kind of interesting. Starting off here with OpenAI, all of these models always get released and you see, oh, it's 5% faster, 10% faster. You'll see across the board, the HumanEval test or benchmark is used in basically all the releases from 2020 till 2024 now. And you know, it is a good test for general coding abilities, but it falls short in a lot of different ways. So we've got Claude 3.5 Sonnet's release here. Scrolling down, I actually love this chart that they put out. It really signifies, I think, the leap in which Claude 3.5 Sonnet has made in the intelligence to cost ratio. Really incredible model. The frontier intelligence at 2x the speed, I think, is pretty spot on for this. I do truly like the work that they've done, and I think the advertising here is pretty good as well. For the benchmark, they're showcasing HumanEval. The 92% correct with zero shot is awesome. I mean, like for the speed it outputs, the cleanliness of the code, like, this is a great model. So we'll see what it performs like in the BigCodeBench. Again, a lot more challenging exercises. Can this more streamlined model stack up against the big frontier models? It might be faster, it's cleaner, but does it really stack up in these hard coding challenges? We'll see. So the Gemini models, so they're obviously got their whole set of different models, Ultra Pro, Flash, and Nano. Again, they actually take a different approach. So most of the other ones are always showing HumanEval. They've actually done their own set of Python, I believe, coding tasks here, and they're keeping those close hold so that they're not exposed to the internet and potentially contaminating results. I will say the problem for me here is that it's hard to gauge their models against others where they're showing 77% completion rate and 82. It's great. I'm assuming that's kind of comparable to the HumanEval numbers, but you know, it's hard for me to compare. So I don't know how much I love that they're creating their own. I would rather the community use BigCodeBench or something like that and start posting that on these release pages more. Entrant into this community is DeepSeek. It's a startup out of China, and I think they're doing some amazing stuff. The benchmarks don't lie. This is a force to be reckoned with. The price points as well that they're coming in on these APIs to use these models are just incredibly low. I'm talking, so GPT-4o mini coming in at pennies per input for 1 million tokens, and honestly 30 cents or 25 cents on the output per million tokens. Like incredibly priced models, not as fast as something like Claude 3.5 Sonnet, but wow, like, I mean, look at the coding benchmark here at 84.8% correct. For the HumanEval score, right behind some of the frontier best and brightest models out there, and they're doing it at a fraction of the cost. And it's just a really intriguing, I think, startup to follow and see how big they really get. So DeepSeek That's a big contender in our lineup here. Introducing Meta here. So Llama 3, they have some fragility to some of these models, I'm not gonna lie. So we'll showcase some of that when we're looking at the output, but they do decently at their HumanEval results with the 70 billion parameter model with 81% here. But you'll see a pretty significant drop off, honestly, for Meta in these BigCodeBench exercises. That might be indicating like the robustness of the cognitive abilities of this model. Maybe there's some underlying, like, I don't know, inabilities to comprehend natural language, which BigCodeBench is using more of. So yeah, an interesting result here that we'll see in just a bit. A fun one to throw on here, the brand new Llama 3.1 405 billion parameter model. I don't even know like what this is analogous to. I was using ChatGPT to understand that scale. I don't know honestly what GPT-4o and Sonnet 3.5 are as far as parameter counts. I don't think those are fully disclosed. But Llama being open source and them having this transparency about the model sizes and parameters and weights, it's truly astonishing, the size here. So as we scroll down, they did a cool comparison here from their previous models to now. So 3 to 3.1, you'll see in the 8 billion parameter model, the HumanEval scores here, 72 now from 60, 80, which this one's kind of interesting, I guess, kind of down here, but I'm not gonna knock them on that. But the 405 billion parameter model, which just kind of seems absurd to me, really getting up there with, so that's just 1 percentage point behind GPT-4o. So kudos to them for figuring this out and like really cranking up the intensity of their parameters and size. Jumping into the background here, HumanEval, it's been around since 2020. OpenAI created this when they were originally creating the Codex model. They wanted a way in which to grade the model's performance in a repeatable way. Of course, us as coders, we always want to have something repetitious and easy to understand. So they created this data set. It's about 165 questions in Python. They have the prompts and then they have the tests. It's kind of a black box test, as we'll see most of these are, where they're wanting to basically evaluate just the correctness of the output, not the semantics of the code. So every model can write them a little bit differently. That's okay. It's just, are the outputs correct and do they align with the tests? So this has been out here for 3 years. There's been some different additions, like Eval Plus has been out there adding to and modifying some of these, doing the mostly basic Python programming tests as well. So there's some other tests out there that are interesting. Again, we'll jump through this pretty quick just to show you. The benchmarks here are really interesting. Now, we are purely looking at LLMs for this Olympic challenge. There are some contenders out here. I won't call them contenders because it's a different class, so we need a whole nother video to discuss this, but you'll see at the top here, this is the code generation on HumanEval. This is the best benchmark leaderboard that I've seen on the internet so far, most up to date, and they're including these other algorithmic LLM applications like Debug Like a Human. Very interesting, coming out at 98.2% correct on the HumanEval score. If we jump over here, they're doing some interesting stuff. The one thing I'll say here is that I think first and foremost, is this model, the way in which it works is it has to know the correct tests in order to backfill the code for that test. So jumping back to the benchmark, the second interesting one that's not just an LLM zero-shot output is the agent coder. I actually like this a lot because it is a 3-agent kind of algorithm here where there's a programmer, a tester, and then a test runner agent. I like this solution. I think it's really cool. And so looking back at the HumanEval results, the agent coder here twice on the top with GPT-4 Turbo and GPT-4. I mean, great results, right? So just had to shout out to the agents out there and the people doing algorithmic work with these LLMs, like pretty awesome stuff to see these performance increases. And just one last note on the, I think it's the agent coder GPT-4. If you scroll down, you'll see 96% completion success rate here for agent coder. If we search GPT-4, obviously a lot of these models are using GPT-4 at the top, but we have to go down all the way to spot 20. It is a 20% increase in efficiency or accuracy using the debug like a human. And granted, it's getting more context in it, but the iteration loop to get to near perfect is really awesome. So again, pretty cool to see the innovation and the use cases there. It's intriguing to like get a little vision into where we're headed with these, you know, LLMs and combined with these tools like and debugging processes and agents. And you know, it's an interesting future, and I'm excited to analyze like where that's headed. One quick insight, I wanted to jump into Copilot Workspace. So we've got these, you know, proof of concepts and papers. This in technical preview I think is super intriguing. My book, Programming with GitHub Copilot, takes you from zero to all the way through enterprise applications, and I really think Copilot Workspace in the enterprise is going to be a game changer. Can't wait to get my hands on this and have this come out. But as far as agents go and having agency to these LLM style code producers, this is what to look out for. So I definitely wanted to highlight that in the agents section here. I'm pretty excited about it. So check out this. There's some videos in here for you to investigate. But we'll keep rolling on here without further ado. All right, so down to the BigCodeBench repository. We're here. Let's analyze it a little bit. So they did a great job of, I think, presenting what this model is all about, what their philosophy is. They kind of tout themselves as like the evolution of HumanEval. And I think rightfully so. They've done a lot of great work, and they've kind of rethought how they can create these sustainable tests. In the era of the internet where things are exposed, they need to create things dynamically, but I like how they have the human in the loop to validate things. So let's jump down through this kind of like a release documentation for their coding benchmark. All right, so looking at this chart, I really like the way they visualize this with the depth versus breadth. And you'll see HumanEval over here, and you know, everybody's touting this as like, oh, I'm 96%, I'm 100, near 100. Well, it's lacking a lot of practical applications. And so that's why I really like BigCodeBench. And I just think it's awesome to see how they're approaching this problem of evaluating LLMs, because if it's not truly useful to your everyday, like the HumanEval tests are very algorithmic, very targeted at programming Python specific, like very nitty gritty, you know, very logical functions. It's not always practical for developers in the everyday world to be doing that, but it's very practical to be pulling in libraries to accomplish tasks and chaining together different thought processes in code to accomplish something valuable. So I think that's the big differentiator here in BigCodeBench, is that they have value-based kind of prompts that are truly representative of things that you'll find on Stack Overflow and be curious on how to implement. You'll see the example that we go through in just a minute. and it's an intriguing example, a little complex, but it's something people have been searching for on Stack Overflow and other things like that. So love these examples. Wanted to jump here to the prompt styles. So there's two tests with BigCodeBench. They have the complete prompt, which is similar to the HumanEval, where it's like complete this function and then, you know, type it all out underneath it as the LLM. They also have the instruct prompt, which is I really like. So this is a natural language requirement, more similar to what you would get in your ticket or whatever it might be if it's a GitHub issue or whatnot. It's interpreting something a little bit more natural to the human language into what would be a code solution. So I really like the instruct prompt, and it's kind of funny on their leaderboard. They list that one as the vibe check. So I think that's pretty awesome that they're having fun with that as well. Scrolling down, one little background here before we jump into things is the way in which they're creating these. So they have a huge repository of these tests. Again, they have 1,100 of these that they're running these LLMs through the tests. They have this big repository from, I think it's called ODEX or ODEC. It's a data set with prompts and intents, and they're taking that, using a kind of a human in the loop here to create a more robust set of instruction, also putting in the tests around that using GPT-4, it looks like. And what they do, which I really like, is that they have qualified human experts that have over 5 years of experience take a hand-picked number of these tests that they're generating to ensure that these are like attainable by the expert population of that language. So in this case, it looks like they did 11 human experts, and they were able to achieve 97% efficiency or correctness in those results. So more on this to come. The LLMs are pretty far off from that. I'm just, HumanEval more basic. It's hard for them to scratch that, 98% correct. And you'll see the LLMs falling far short on these more difficult benchmarks. Sad to say for the LLMs out there, but better for us programmers, a little more job security, right? So jumping in, all right, the LLM champion of 2024 today. Well, let me switch this. I think the hard data set's a little too hard on them. Let's give these LLMs a little bit of break. So what I'm gonna do is I'm filtering this by average percent correct, and I'm giving that on the full data set. The hard data set is the hardest of the 1,100 questions. It's 150 of them, and it looks pretty brutal. So I'm gonna clean it up for them a little bit, help out these LLMs. So interesting number one here. I mean, OpenAI is innovating. GPT-4o is an incredible model. And here it is solving 56% of those questions correctly, which honestly is pretty great given the complexity of these problems. And I'll show you really quickly after this an example of one. The dark horse in this race, taking bronze and silver in our Olympic challenge, is the DeepSeek startup out of China. The V2 chat, understanding natural language, maybe the complexities and nuances of harder problems, solving this at a 54.1% rate. And then just a tick behind is the Coder, and I don't know, DeepSeek Coder right behind their chat version, but incredible results, to be honest, for them. And again, the price points for those APIs to use those is fractions of a dollar. So it's just crazy in comparison. We'll look at the chart here in just a second, but you've got gold, silver, and bronze right here. In my eyes, this test is really is tough, and it's representative of the true best LLM coder of 2024 right now. And so kudos to GPT-4o for taking gold. That's awesome, but really respect the effort coming out of that startup DeepSeek. Let's jump into this right here. So this showcases the data behind it. I'm just gonna let you guys jump into this as you please. This shows the complete prompt, instruct prompt, the solution that is necessary as far as like actually getting correct output. Again, not graded on that. They're graded on the test output. The compliance to these tests. So these tests are ran against the generated code, and if it passes all these tests, that's a tick for that particular problem. So 12 pages of this, lots of great data here to analyze, to understand how they're going about each of these. Tons of libraries being used, and like I showed from that chart, from the depth of knowledge in a particular problem set to the breadth of knowledge for all these different problem sets and scenarios and libraries. Really great job again with this test set, I think, that they've done. All right, so I constructed this table. It's got the models that we've been talking about and the prices of the APIs that are available for them. The only one that I don't know the current pricing for, but I wanted to throw it on here, was the 405 billion parameter Llama 3.1 model. This one's probably gonna come out, I would assume, closer to Opus because it's huge. And so that's 15 and 75. I don't know, maybe it's gonna be a lot less. That just is a huge outlier as you see in the costs here. So just want to absorb this for a second with y'all. We've got GPT-4o, our champion, our gold medalist. And then we've got our two DeepSeek models here coming in at second and third. And just look at the prices though, for their API, it's just pennies, right? In comparison to something like 5 and 15. All of this adds up if you're using these things for anything noteworthy at scale. So really cool stuff to see. One of my callouts I want to make here is the GPT-4o Mini coming in at a fraction of a dollar per input output as well. Really stacking up pretty well on HumanEval. And then I think, holding its own on these more complex tasks and inference speed, right? So it's a lighter weight. And similar to Claude 3.5 Sonnet, being able to hold their own here with these smaller, models against these big frontier models. Now again, look at that. Inference speed is interestingly slow for these DeepSeek models, but like for the price, if you're actually building with these models, you have to look at some of these cheaper ones and see, again, with trial and error, which one works best for you. This chart down here just kind of represents the bang for buck. So you'll see Opus and Gemini 1.5 Pro and GPT Turbo. Some of these are pretty pricey for what you're getting. And then you look at the like non-existent, essentially pennies on the dollar, models really actually still holding their own through the BigCodeBench exercises. Okay, so right here is the legal protection links. I'm gonna skip over those for this video, but you can browse those as you will. I did list the yes or no's here in this chart. And as I mentioned earlier, DeepSeek does not have any protections for you legally if you were to be confronted with a legal suit. Most others do. Meta, due to these models being open source and they don't actually host these APIs, they don't have legal protection specified. There might be something out there, but on to the examples. All right, so I have 3 of these stacked up. We've got GPT. Let's switch this to GPT 4.0. We've got Claude 3.5 Sonnet. Our second and third place here, bronze and silver. Let's go with DeepSeek V2, which this is the chat version here. So what I'm gonna do is I'll pull up the coding exercise for one of the BigCodeBench exercises. So I've got this one, the 1100 exercise. So the complete prompt is the one I kind of want to use. This one's generally easier for them to complete. It's harder for them to understand the more natural language prompt. So I'll try to help these models out a little to complete this one. Again, they're kind of like a 50-50 on whether or not they do these ones correctly. So I'm gonna throw these in here, and just to get a visual on how they're like inference speed is and processing power. We'll just try to click these as fast as we can. All right, so 3, 2, 1. All right, so, both of these kicking off. It's interesting how Claude 3.5 Sonnet takes a little bit longer to kick off, but it really like plows through the code once it knows what it wants to do. And I think it's speed of like auto-completed code, essentially like code completion. It's just clearly on another level of speed. I think like they said in the advertising, like 2x the speed of other frontier models with the same kind of ability. Like it's really phenomenal. I know it didn't quite make the podium, but I'm a big fan of the work that they've done there, and it's just pretty mind-blowing, the speed. Let's start with our gold medal winner. So we've got a lot of extra text here. It kind of set its context for its solution within the code, where I think Claude 3.5 Sonnet does more of a upfront, text-based context. So they all have their nuances in how they're producing these code. So what I'm gonna do is just grab this function from the top, come down here. I've got my VS Code set up with the Python file, and I want to basically I'm gonna throw this function in there from GPT 4.0. I've got my unit test import. These are the required imports that are from the test. So I just wanted to, leave everything the same. I'm just, inputting the model output as the function. These are the tests that they have from the test case. So 5 tests. I've noticed some of them, or mostly all of them, fail with the empty case. Should return, the empty array. Has a lot of trouble with that normally, so let's see how it does. I think I have to save. So we're gonna execute this file. All right, so we failed, we had an error, and I think it's due to the 0 case. Let me comment this out. Let me just rerun that. Yeah, our gold medalist, did pretty good. Just on this, empty cases are hard to account for, that defensive coding, right? And maybe thinking a little bit more step by step versus, hey, this is my problem and I need to solve it. It's more like, what are my basic understandings of coding? What are my good coding practices? And maybe some of those will be embedded into these models as time goes on, like defensive coding and null reference exceptions checks. As we know, that's critical to global infrastructure. Let's go on to this one, Claude 3.5 Sonnet. All right, let's see if we can get all 5. It's clean code and has another error. So I think this is the same issue. Let me just double check there. You know, really close as far as like what they're capable of doing, right? These are kind of difficult operations to consider, right? Removing URLs from the string inputs, you know, creating this kind of format for the TF IDF matching schema. So this, so overall, I mean, I'm pretty impressed with both of these models being able to get 4 out of 5 tests. But so as you can see, like that's a failure for the BigCodeBench result. But you know, they're actually performing pretty well. So as they tune these just a little bit, or as they get better just a little bit more, these numbers from the 50s and 60% completion rates could maybe get up to that 80, 90% and really have some solid code being produced by these models. Just to jump back, this exercise is kind of interesting based on this this kind of algorithm for word importance within lists. So it was new to me. I have this link in here if you want to check it out further. But this is term frequency inverse document frequency, and it is the importance of a word within a sentence. And it's interesting, like, you know, just to, you know, at a high level here, these descriptive words are more important than these because good and sweet could be describing most anything. And these are very particular things, like you're most likely talking about a salad. So anyway, kind of a cool weighting algorithm. And, you know, like I mentioned, plugging into these libraries in a realistic world scenario, like a lot of search engine kind of word priority measures are done with this type of tooling. And I don't know what Google's using today, but you know, as far as the Wikipedia was concerned, it was, you know, kind of used for a lot of different search algorithms over the past decade. So pretty cool stuff to see them trying to fix and do these things. So jumping over to our DeepSeek V2 coder. So this is the function. I really like how this one came out. It's got the steps commented. It looks clean. I'm a fan of it. You know, I think, you know, proof is in the output here though. It looks pretty decent, compact and nice. Definitely took longer to infer this result than the others, but let's see how it does. All right, 1 error again. So I think they all are just on the cusp of getting this last one right. I think this last one's, this test case is holding them up, and you know, just like the tiniest nod towards that in the description probably would have like made them get this correct. But again, like, they need to know these types of things as programming assistants. This zero-shot scoring is really important for them to get things right on the first go and not have to iterate. You know, the more we iterate, the more times we're wasting just going back and forth with these models. We want the output right on the first go. So 3 failures technically, but you know, 4 out of 5. I'm gonna say they did pretty great. All right, on to our last 2. Quickly, the newest meta model, the 405 billion parameter one. Let's give it a go here. I think that's my latest solution. Let's grab maybe. All right, and let's fire this up at the same time. So we've got the high-stand Gemini model there. I think it's might be the 70 billion parameter. I'm using the 1.5 Pro. And the price points here versus what we're dealing with, unknown prices, but definitely more than this. So let's jump back here, see their outputs. It's still working. This one is done. So interesting, you know, the enormity of this 405 billion parameter model is slower. So, you know, maybe it's being used a lot and they're throttling people. These are some, you know, network things that might be occurring. It just got released today, so I'm sure they're getting hammered with these requests on their server. But yeah, generated by Llama 3.1, 405 billion parameter model. So pretty cool to see the output though. Let's test this one and see how it does. So jumping back into VS Code, let's go to our file. And I like the look of the code, looks clean. My guess, We got a problem with the last test. Well, look at that. Oh yeah, 5 failed. So some kind of syntax error, huh? Interesting, interesting. Did I copy it correctly? I think I did. Comment below if I messed something up, but frontier model, massive size, fell short. Interesting, very interesting. All right, so we've got our task here. Let's grab that. See how it does. Okay, clear the console, rerun. And 5 errors on this one. Yeah, I think this is kind of indicative. I want to jump back into the Google and Meta results here. So I'm going to highlight these rows. The drop off here, you know, and also the original HumanEval score is not even that impressive, to be honest, in comparison. I know that this is like always in context here. All these models are improving so rapidly and great, but really it's a large drop off and a clear differentiated a kind of ballpark here when you see it not get any of those tests right, and it's those 4 points less than GPT-4o, or sorry, 6 points less. Like that really showcased, I think, the inability for those models to get there. I mean, the Llama 3, 70 billion at 49, really coming in near the bottom of these largest models. Like, I mean, right there with Gemini Flash, which is interesting. So, you know, really low scores there on those, and as you saw in that output, failing all the tests. So GPT-4o taking gold, followed by DeepSeek in second and third there. Really impressive stuff. I hope you learned a little bit about these models, how they're being evaluated. Maybe we all need to push for, you know, BigCodeBench. I think it's a great project. Definitely check the link out in the description. It'll give you access to all the links that I just showed today. Comment below if you have any models that you think outperform these, and any ideas for anything you want to see in the future. Let me know. Hope you had fun today. All right, I'll talk to you later. Bye.